Hello, my name is Malini Kamalambal. I'm a platform architect here at Humanitec. In this video, we'll look at how we can use the Humanitec Platform Orchestrator to create the multiple environments you might need during an application deployment. Today, you likely already have some infrastructure as code modules to help you provision resources in the cloud. What we do with the Humanitec Platform Orchestrator is extend the power of those modules. We help you change those modules from provisioning isolated infrastructure components into building a whole application environment for deployment. And so let's take a look at how we do this. For the demo, I'm going to use a simple application. It's a banking demo application. The application has a very simple front end and two backend microservices. The front end depends on a DNS entry, so users can access the application. And as far as the backend services go, we have the Money API, which has a dependency on a AWS S3 bucket, and then a user API, which has a dependency on a MySQL database. Now, before we go into how the Platform Orchestrator can help you get the application deployed in multiple environments, I'll start with a brief recap of how the Platform Orchestrator works. So we have two different personas in play here. The first is the developer persona. And from a developer perspective, what they're going to do is they're going to create an abstraction of what the application looks like and what dependencies the application has. And then we have the platform engineer persona. The role of the platform engineer persona is to define how to create the resources that a developer might need in a specific environment. For example, if it's an S3 bucket in development, how can it be created? What Terraform modules should be invoked? When should it be invoked? And so on. These are the rules that the platform engineer specifies and is available to the platform orchestrator. Now, when the developer sends in a request, an abstract request, which says, I want to run an application, it has a dependency on a S3 bucket and a MySQL database, the platform orchestrator will look through the rules, find out how to create those resources, and then it'll go ahead and generate the configurations needed for both application and infrastructure in the context of a specific environment. So here I have an example of staging. So the orchestrator will know that when the request comes in for a DNS, a MySQL database, a S3 in the context of staging, it'll know to look through the rules that has already been defined and then find out how to create those resources and then generate the configurations. This process is what we call dynamic configuration management. And the platform orchestrator goes through this process for every single environment, for every single deployment, which means that your teams no longer have to manage the configuration files separately for each environment because it's all dynamically generated by the orchestrator. All right. So now that we have an understanding of how the platform orchestrator works, how it can generate configurations for each environment, let us go into the demo. Now, before I start the demo, I'm first going to assume a developer persona. And remember the application that we just saw, which has a front end and two backend microservices. I'm going to assume the role of a front end developer. So typically in a development workflow, the developer will locally develop the application, they will go through some local testing, and then they will need an environment where they can test this, preferably something that looks like what your QA teams or production or staging environments would look like. And typically that is not done because the testing is usually limited to the laptop because provisioning environments is a major pain. Now with the platform orchestrator, because we are simplifying how environments are created, it becomes very easy for a developer to test in an environment that looks like a real production environment. So that is the first step in the application development. The next step is the developer is happy with whatever they've done. They are ready to open a pull request against the code repository, GitHub, GitLab, whatever. And when they open a pull request, it'll be really cool if they can see the changes running in an environment so that the reviewers can also take a look at it, make sure that this is exactly what they want, and so on. And this is where the idea of ephemeral environments for each pull request comes in. An environment that can be spun up and spun down on demand. Now we have a separate video that goes through this in detail, so I'm not going to go into the details of how to create ephemeral environments for pull request, but we'll have a link down below in this video that refers you to the details of that. Okay, so now the pull request is done. The reviewers have gone through the review process. It has been approved and it's ready to merge. The next step is promoting it to a higher environment, like staging. And this is where the orchestrator comes into play again. The orchestrator will know that it has to deploy this application in the context of staging. It will know the rules defined for that, and it will know how to dynamically create those resources and get those applications running, which means that there is less time needed for your developers. There's less time that your developers need to spend creating new configuration files for the staging environment, and there's less overhead for your platform engineering teams because they're not manually creating a new MySQL database or a new S3 bucket for each deployment of each application. All right, so now let me go back to the demo. I'm going to start with the front-end developer persona, and I have some application code here that I've already done. So this is my front-end application and I already have some code here. And the next thing I want to do is get this application running. And in order to get this application running, we first need, as a developer, I first need to create that abstraction. If you remember the picture earlier, the developer's role is to write the application code and an abstraction that tells the platform orchestrator what the application is and what dependencies it has. And here I have the abstraction in the form of score file. And in the score file, I specify my application and what resources I need. In this case, my front end needs a DNS entry, and it also has a dependency on a couple of backend services, the money API and the user API. And those are the dependencies I've specified in the resources section, right? And now that I have defined my abstraction, I'm ready to get this deployed. So what I'm going to do next is I'm going to send this request to the platform orchestrator. So I run a very simple deploy script, a very simple one-liner that I have here, which uses the core Humanitec CLI to deploy this application in the context of development in the bank demo application. And then I also have some credentials to authenticate myself to the platform orchestrator. All right. So let me go ahead and deploy this. Okay, now I have started the deployment process. So let me now step over to the platform orchestrator to see what happens here. So remember the little diamond here, our blue diamond? This is the platform orchestrator, and the interface that you see right here is the UI for a platform orchestrator. And here you can see the bank demo application, and this is the application to which I'm deploying the changes in my front end. As you can see, I already have a development environment, and this is where I'm targeting my new deployment because I'm still at the before a pull request stage. So I just want to test my changes isolated in a development environment. So if I look here, I have seen my deployment running. I have a few previous deployments during my previous development cycles, but now I have made a feature change. So I'm doing this deployment here. So let me see what's happening here. I can see that the front end module and also the dependent money API and the user API is being deployed here. And it just got completed. But before I go into the workload, I also want to take a look at the shared resources because this is very important. So here you can see the target Kubernetes cluster and the namespace that this workload is going to. So if I take a look here, I can see that this specific deployment is targeting a resource type Kubernetes cluster with a resource definition ID bank demo shared. It's also giving some additional details telling me which exact Kubernetes cluster which exact EKS cluster in AWS is being targeted for this specific deployment. Now, how did the platform orchestrator figure out where to deploy? You can likely guess it is with the rules that the platform engineers have already defined in the platform orchestrator. And the rules is in the form of the resource definition ID here. And if I take a look at this specific resource definition ID, I can see that it is targeting the Kubernetes cluster that we saw here. All right. And the reason this specific Kubernetes cluster was targeted was because of the matching criteria, which says that when a deployment is done for an environment type development, this is the Kubernetes cluster to use. Now going back to the application that we just got running, let's go back to the workloads. Let's look at the front end. So you might remember the front end has a dependency on a DNS entry. So let me go down, look at the DNS entry here. This was provisioned. And you can see that a new DNS entry was created for this deployment. And if I go look here, I can see that I have a new instance of the banking application running. All right. So this is how I, as a developer, can deploy my application, see how it works, test my code changes even before I open a pull request. So now that we have gone through this application deployment in the development phase, you can see how easy it is for a developer to get an environment that looks exactly like production. Now, the other thing I want to mention is, let's say I want to create additional environments of type development. Maybe I have some team members who want to see what my change looks like. I want to give them an isolated environment so they can go ahead and maybe make changes there, test their dependencies there. And what I can do for my teammates is I can create a new development environment for them. So I can create a new environment. I can clone from my existing, and I am choosing the development environment type as development, and maybe just call it dev alpha and create it. So now I've created a brand new development environment for my teammates. I have some draft deployments here, which I can review and deploy to create another instance of my application running for my team. So I'm going to deploy this. And this will now create a brand new environment for my teammates, which will be exactly similar to what I created here in development, but it will be targeting maybe another Kubernetes cluster if I've set the rules for that. But in this case, I know that all development type deployments are going to the same Kubernetes cluster, so it will be in a different namespace in the same Kubernetes cluster. But if I need to, I can very well point it to another Kubernetes cluster or another DNS rule. And it's very, very flexible in terms of what you can do. You can limit who gets access to which environment, and all of this becomes very easy for you to manage. So now I have this dev alpha running, and it's still deploying. We'll give it a minute to deploy. And while it's deploying, another aspect I wanted to call out is the idea of pausing environments. When I pause an environment, what happens is it can scale down all of the replica count to 0. This is very, very useful when you have multiple teams sharing a Kubernetes cluster, because they might be working in different time zones, so they may not all need to have these applications running all the time. So let's say a developer starts and ends the day in Europe. When they end the day, they can just pause the environment. So maybe when their teammates in the US come online, they can use the same Kubernetes cluster to do their deployments. All right. So now we have this dev alpha environment running. I can go look at this front end and see that it created a new DNS entry for me, bank demo dev alpha. The previous one we had was just bank demo development. because that was the name of the environment. And here we have a bank demo dev alpha, which I can load and see it running. All right. So now we talked about pausing the environment, which is what I want to show you next. So I pause the environment. So it tells you that all the workload counts, replica count will go to 0. And now if I go to you can see that the workload is paused and the replica count is 0. So far what we have seen is how a developer can easily deploy an application to development, how we can easily clone multiple environments based on a standard base environment that you have created. And we have also seen how to pause environments so that you can keep the cost in control and make the most efficient use of your Kubernetes resources. And we also talked about the ephemeral environments for a pull request that you can see in a separate demo video. So now the next step in a standard development process will be promoting these changes to a higher environment so that maybe your QA teams, your UAT teams, they can do the testing needed. And so for that, I'm going to create a staging environment. So I go back to the create new environment. I'm going to clone from the existing development environment, and my environment type is going to be staging. So create a staging for bank demo, and now I have a brand new environment. I have some draft deployments, but nothing has been deployed here yet. So let me fix that and go ahead and make the deployment. So I'm going to do review and deploy. Now, when I'm doing a deploy in the staging, the platform orchestrator is going through the same process. It's going to read the workload definitions. It's going to find out what it has to do. And then it's going to look through the rules that the platform engineers have defined for this specific environment. And once it has found the rules, once it has found out how to create a DNS entry, how to create a MySQL, which Kubernetes cluster to target, and anything else that it needs, it will go ahead and create the resources and also do the application deployment. So let's see what's happening here. It's doing the deployment, and you can see that it's doing the front-end money API user API. Let's see if the shared resources is populated yet. Not yet. We'll give it a minute for it to run. Now that the deployment is complete, we can see that all 3 workloads are now healthy. Let's first take a look at the shared resources. Now we have the same Kubernetes cluster, the namespace, everything that we saw earlier for the development environment. But the only difference would be now it's targeting a different resource definition ID, which in turn points to a different Kubernetes cluster. So now we are pointing to the staging cluster for the staging deployment. And you can guess the reason this happened. It is because the staging Kubernetes cluster definition, this specific resource definition, has a matching criteria set for staging. And that is the reason the deployment to staging was went to this specific Kubernetes cluster. All right. And the same rules applied for all the other resources as well. So if we take a look at the DNS entry that was created, you can see that it pointed to a staging DNS, and in turn, the entry that was created has a staging subdomain. So if I load that, you can see that a new instance of the application was deployed for the staging environment. And the rest of the process is very similar to what we saw so far. But now you might be thinking that, yes, this is all good. It's really cool that a developer can deploy to staging, then production, and so on. But in real life, you don't want your developers to be deploying to environments other than their own, right? Maybe the staging and production, it happens through your deployment pipelines. You don't want a human doing any of those. Or maybe you have a separate team, maybe an operations team or a DevOps teams who handle these deployments to other environment. So you want to control who gets deployment rights to specific environments. And that is something that you can also control by you can do that when you create an environment type. And this is something we haven't talked about earlier. But the environment type is basically a way for the platform engineers to define what are the different environments that can be created. All right. So here I have development, staging, test, production, and so on. Let's say just for the fun of it, I'm going to do a QA demo environment, and I can call it just for QA. And then once I create the environment, I can define who gets to deploy to this specific environment. If I take a look here, I can see that by default, I'm the only one who has deployment rights to this. But maybe it's not a good idea to have me as a deployer here because I am a front-end developer. Why should I deploy to a QA environment? And for that matter, I shouldn't have deployed access to staging or production. So I can easily revoke access here. And then let's say you can give access to just a platform engineer. That's me. I have a platform engineer hat now. So I can just give platform engineers access to deploy to specific environments. So this way you can control who gets access to which environments. You give developers an easy way to deploy to multiple environments, get through their development cycles fast. You give an environment for QA teams to see those changes fast, get through this test fast. You can clone new environments for your pull requests and so on. But at the same time, you can also strictly guarantee the controls of who gets deployment access when it comes to the higher environments, if that's the model you want to choose to. Now, going back to the application, we deployed the bank demo application. We created a development environment for your developers to test before they even open a pull request. We talked about creating ephemeral environments for PRs. We created a separate environment dev alpha of type development for your peers in the development to test about. We saw how we can pause environments to make the most efficient use of your resources. And we also saw how the changes can be promoted to higher environments like staging and production. I hope this gives you a good overview of the environment management with Platform Orchestrator. And we look forward to seeing you in the next demo. Thank you.